I will tell you about EVERSE. So we have these two projects co-organizing the school, OSCARS and EVERSE. So EVERSE is a project about software quality. So you can see why already it's an organizer of the school. So the project started because we all know that reproducibility is hard, and it depends a lot on the quality of the software we develop. So we wanted to structure it a bit that and see how we can help researchers improve software quality in a community-driven way. So the project started 2 years ago in March 2024 with the goal to build a new European virtual institute for research software excellence. So we are now 2 years in the project. There's 1 more year to go. It's a 3 years project with 15 beneficiaries, which are presented here. So you may recognize some of them, maybe even your own institute. It's a European project, of course, in the framework of EOSC. It's also represented by all the clusters. So Romain told you there are 5 clusters, which are here: environmental science, the life science, astronomy and particle physics, photon and neutron science, and social sciences. So we try to include all the communities and to build something all together. So what have we done for the 2 first years? The main outputs at the moment. First, the network. I will detail a bit just after. So a network of people and institutes that want to improve the quality of software. The RSQKit, this is something that you can already use and that can be very useful for you, where you can find a lot of resources and knowledge to improve software quality. The tech radar, I will show just after, and the training and recognition framework, so where you can find more training resources about software quality and software development. So the network, as I said, is a community of people and institutes to improve software quality. And this is something you can join actually, so you can just go to the website and join the network if you are interested in this topic. We also work a lot on a framework to think research software, so we don't reinvent everything and what is research software and how to think about it. Of course, we try to use previous work. So I can give you here a definition of of research software. There are many definitions actually, but I find this one quite good. So it's a part of research discovery process which might require specialized domain knowledge and is by itself a contribution to science and research. I think that's an important part, that it is really a contribution to the research, and it was developed with the intention of being part of the research. And the goal for EVERSE actually is to make this research software a first-class citizen of the science output. So meaning that it's as important as, for example, a scientific publication. In the framework, to think a bit about that, we have different, let's say, things to think about. We use the software tier categorization, so this thing, which is used to classify software in different categories. So going from analysis code, so this is the most abundant kind of software that you find, for example, a script to analyze some data. It's often developed by a single people, a single researcher. And so the reach is minimal, but this is what we have the most. Then you have some prototype tools. It's maybe small libraries developed by a few people or a few teams and used by this team, so by a small community. So it reaches a bit more people, and it starts to need some good practices to develop and to maintain. And then you have what we call the research software infrastructure. So this is big libraries or big software that are developed or used by many people across different institutes or even domains. Think to stuff like PyTorch, for example, developed by many people and used by many. And this kind of software needs even more good practices, more maintenance, extra to keep a good level of quality. And then we have the software lifecycle. So maybe you've heard about that already. The software is not something you do once and just put in a corner and publish it and it's over. It's something you need to maintain. So there is a cycle of life where you think about what you want to do, you plan, you define your requirements. Sometimes this can go quite fast, but you have to think a bit why I want to develop a software. You do some design, then you actually develop the software. And then it goes into usage, evaluation, maybe by other people. You can publish the software and get some feedback, or it's getting reused by others. And sometimes with this feedback, you need to go back to designing, thinking about your requirements, etc. Okay, about the RSQKit. So this is actually a web page where you can go. It looks like that. And actually, I can maybe even open it. Can I click on that? Okay, let me open it directly. Here, so this is this web page where you can find a lot of knowledge about research software quality. For example, different roles, so you can see what are the roles in around research software. Most of you are probably researchers who code, but or trainers here. But you can also have policymakers or principal investigators that will define what the software will do. And then depending on these roles, you will have different tasks. So if you want to do something specific with your software, and we will learn a lot about these tasks during the week. But for example, I want to cite software. How can I do that? How can people cite software? And you will see the very important information you need to know to do that. These tasks, they can be linked to some tools that can help you achieve these tasks. And these tools you will find in the, I will come back after to the indicator, in the tech radar. So this is a dashboard, so also a website, a dashboard where you can find the tools that help you either evaluate or improve research software. So it's this visual dashboard, and it's divided into quality dimensions. So the dimensions are, it's this list. Well, it's a bit tiny now to read, but it's a list of quality dimensions. So to categorize the quality of software, you can think that into different dimensions. They are not all, well, the quality is very large, but you can think of, for example, security It's one aspect of quality, but also flexibility or fairness is one dimension of quality, or maintainability, etc. So these dimensions, they help us categorize what we want to do, to achieve, and the tools we have at our disposal. And we can even have into each dimension some indicators. So also here we have a list of indicators that we reuse from different communities. Indicators are metrics that will help you measure the quality of a very specific aspect. So, for example, one indicator in this list is no leaked credential. So it just assesses that your software didn't leak any credential, and you have one tool to measure that. So with these tools, you can go into what I like to call the quality cycle. So start with the RSQKit, see what you want to do and how to do it. Define what are the indicators to do that. Find the tools to help you achieve or to improve your goal. And then we have the quality pipelines that use these tools that you can use on your specific software. And we are still working on developing that. And then the pipelines will output some metrics, high-level metrics, using the indicators and the tools. And you can then visualize these metrics in the dashboards, so with aggregated metrics. The two last aspects are still under internal test, but will be delivered during next year. Last part is the training and recognition framework. So this is what, as I showed previously, and that will be used during the school. So we have this, again, website where we collect training events and material that you can use to improve software. And we have this recognition framework, so to promote the recognition of trainers and people who develop software. So this can be reused in your resume, for example, or be shown online on your ORCID profile. Okay. And finally, with all these guidelines, we try to give some policies, high-level policies that we can give also to institutes to improve software quality and to promote good research software and the people who develop them. So I will just briefly read these 5 key recommendations that we have made in the EVERSE policy brief that we released this year. So first, it's essential to establish and maintain European knowledge base for good practices on research software, driven by the communities. We must establish and adopt a common definition for research software quality and of its indicators across domains. So we don't have the same indicators on all domains, but that's okay. We must recognize and reward contributions in research software. So people are really recognized for that work. We must establish and support capacity building activities. So like the school, training activities to promote software quality. And we must capitalize on research software capacities within Europe to build a robust and independent research software ecosystem. With that, I just show you all the contributors to EVERSE and the tools that we developed. Thanks to all of them. And thank you for listening. Do you have any question on EVERSE?